Hey guys, welcome back. So in this video we're going to look at object serialization and deserialization. So what those two terms mean is basically just writing objects out to files and then reading objects in from files. So this is useful, for example, if you have maybe some kind of object and you want to transfer it over a network. Well, that means anyone on the opposite side of the network can just read the object in and deserialize it and then do anything they want to do with it. So for example, let's create a very simple object, class simple object, and actually let me change this. I'm going to create it in its own file just for clarity. Simple object. Now what we're going to do is we're going to maybe store content, some strings inside of it. Let's store an int x, y, z, and then yeah, that's good enough for now. Now what we're going to do is I'm just going to generate some getters and setters. Let's see here. No, I don't want to override, I want to generate. There we are. Select all, go, okay. Alright, so now the way we want to make this object serializable and deserializable is we need to implement the serializable interface. This interface is going to kind of just do all of the magic for us, and it's going to let us, it marks this class as serializable, which means that it can be written to files and then read from files. So now what we can do is we can just do this. Let's first create a file output stream, object output stream, and let's make it point to, actually what I'm going to do is using our new try with resource syntax that we learned, let's do it like that because it's just a better way of doing everything in general. What we're going to do is we're going to create a file output stream, and then we're going to say that it's an, actually my bad, we want an object output stream, right? So this object obj out stream is equal to new object output stream, and now we need to provide some kind of source or some kind of destination. So in order to do that, let's pass in a file output stream that we're going to create using this obj.ser file. Ser files are generally the places where you're going to store these guys. Okay, so now, or where you're going to store serialized objects. Ser is short for serialized, I would guess. And now what we're going to do is generally you don't want to catch the general exception type. You can do this, for example, if you could have an IO exception, and then you could have maybe like a file not found exception, but you can reduce all of these catch statements to a single exception because all of these guys subclass exception. So if you have the base class over here, then you don't need to add other catch statements. But this is generally not good practice because you want to be able to handle each exception separately and have good output for each one that might happen. So in this case, we know that we're probably going to get an IO exception E, and so let's just stick with that for now. Okay, now that we have that, what we're going to do is using this object stream, let's write an object. And so the object that we want to write is going to be this simple object that we've created here. Let's generate a constructor. Alright, so let's see here, generate constructor using fields. We're going to pass in all of these guys into our constructor. And now we're just going to go here, and we're just going to do new simple object. And let's give it some contents. These are some random contents. Let's give x a value of 1, y a value of 2, and z a value of 3. And now we just do a dot close. So we're going to close. Oh, actually, we don't even need to close it because we have our try with syntax going on up here, right? So now we're just going to let's print out the stack trace in case we get an error. And what we're going to do now is let's define another try with block inside of here that's going to let us read the contents of this ser file, and we're going to read that into an object. So now what we're going to do is we're going to do object input stream, or maybe I should do obj input stream is equal to new object input stream, new file input stream. By the way, if you guys are wondering why we need to nest all of these file input streams inside of other streams and then pass them into maybe like object output streams, this is admittedly a shortfall in the Java language. Like, why is this so complex, right? But just try to think about it in terms of this, right? Like, you need to construct some kind of object input stream, but where is your data coming from? Well, it's coming from a file. In order to read from a file, we need to use a file input stream, and so we're going to construct a file input stream. In order to construct a file input stream, though, we need to provide a file, and so that file is, we're going to make that file using this obj.ser name. And okay, so now what we're going to do is let's print out this exception in case it ever does happen, right? So we know what's going on and where. And what we're going to do is we're just going to do obj input stream dot read object. So this is really nice. We're just reading the object, right? And okay, so now we need to add a class not found exception. Catch class not found exception E. Maybe the person who's trying to read this object in, right? Maybe they're across the network and they don't have the same source code we're working with, so they don't have this simple object class. If they don't have this simple object class, then how can they construct an object, like an instance of it, right? So that's what we need to watch out for with this exception right here. And now what we're going to do is let's create, this is going to be simple object data, and we're just going to cast the serialized object, or I guess now it's deserialized because we're reading it, and we're going to cast it to the type we want. All right, finally, let's print out some data. Println data dot get contents. Let's see here, data dot get contents plus space plus data dot get x plus space plus data dot get y space plus data dot get z. And that's all there is to it. And let's run, see what goes down. Okay, so let me, let's see, where are we printing anything else out? Yeah, let me comment this guy out. And now let's run, and this worked pretty well, right? You see these are some random contents, 1, 2, 3, this thing worked exactly like it should. Let's refresh our learning folder so we see the actual SER file. And there's not really much inside of the SER file that we can look at. It's been encoded, and I don't know, I guess it doesn't really make too much sense to us, but this SER file contains the contents of our objects. And what we've done is we've done something pretty remarkable. We've read the object in from memory, or first we've written it to a file, and then we're reading it into memory. So this is particularly useful because you don't even have to be on the same kind of machine. You could be maybe on like a PC, and you could write this object, and then I could be on a Mac, and then I could read it, and it would work. So that's serialization in a nutshell, guys. I'll see you guys in the next video.